So let's start with a brief overview of ISIS. And certainly the very first thing we got to talk about is the acronym. What does ISIS stand for? Well, it stands for Intermediate System to Intermediate System. So that's why I'm not calling it ISIS, because that would technically be wrong to call it that. That's why I'm going to call it ISIS. So it's been around for a long, long time, and we're talking decades this protocol has been around. So it was originally developed by the ISO, the International Standards Organization, to route OSI CLNS packets. Now you might wonder, CLNS, what's that? I've never heard of that before. ISIS is so old that it was actually developed before TCP/IP came out, or maybe right about the same time that TCP/IP was starting to be designed. And so we're talking about like the mid-1980s here, which some of you watching probably weren't even born at that point in time. And so way back then, you know, when the dinosaurs roamed the earth and OSI came up with ISIS, actually the ISO came up with it. Back then, the idea was, okay, we've got this layer 3 networking layer, and the ISO said, well, at that networking layer, the protocol they had in mind to operate there was called CLNS, the Connectionless Networking Service. Did a lot of the same kind of stuff that we think nowadays of IP doing. And the actual protocol that carried the data within that layer was called CSNP, the Connectionless Networking Protocol. So here's sort of an analogy to that. You know, a lot of times when we think of, if I throw the term of TCP/IP at you, well, probably there's two things that come to your mind. First thing that comes to your mind is probably layer 3 and maybe layer 4 of the OSI model. And then when you think of layer 3 of the OSI model, you think of, okay, well, the protocol it's running is IPv4. So the actual data is being encapsulated inside of IPv4 packets with certain IPv4 fields. But technically speaking, if I say, well, at layer 3, I'm using IP, the Internet Protocol, there's more than one way we could encapsulate packets into IP, right? Because we could either be using IPv4 or IPv6. They both sort of fall into IP. In the TCP/IP stack, both IPv4 and IPv6 are examples of protocols that ride in this sort of generic thing called TCP/IP. Well, same thing's kind of true here. Here, CLNS is sort of equivalent to the generic name of TCP/IP. CLNS is the networking layer of the OSI model that the ISO came up with. And then the protocol that actually would encapsulate stuff was called CSNP. And ISIS was originally developed to route that kind of stuff. So back in the 1980s, the mid-1980s, when TCP/IP was coming out, actually back then, they kind of thought, well, this is like an experimental protocol. We're using this just to test some stuff out, but it's never really going to be used big time. I mean, eventually this stuff will fade out, and everybody will be using, CSNP and CLNS to route their stuff. So the designers of ISIS said, well, because TCP is out there and some people are using it, let's go ahead and modify ISIS to carry TCP/IP traffic. And that's actually what we call integrated ISIS. So if you hear that term integrated ISIS, that means ISIS that's been modified to carry IPv4 and then later IPv6 stuff. But the reason why this is important, you might be thinking, well, this is all historical stuff. Why do I need to know about this? Why this is important is because you have to realize that there's two critical things here. Think about your other routing protocols that you know about, like EIGRP and OSPF. One thing they have in common is that both of them were developed to route IPv4 traffic. That was their original intent. Both of them have unique names called router IDs, right? When you're running EIGRP or OSPF, the very first thing that has to happen in the CPU is the CPU has to come up with a name for itself called a router ID. And because those protocols were designed to operate over TCP/IP, the default behavior is that the router goes to some interface, pulls an IP address, and uses that for its name. Well, ISIS, and we're going to get to this in more detail later, also has, we don't call it a router ID, it's got a different name, but it has a unique name to itself. An intermediate system has a name to itself. But it wasn't designed originally to route IP packets, so it's not going to go to an interface and pull an IP address. The actual descriptive name of an intermediate system is much larger than 32 bits, and you have to configure it manually. You have to configure it manually. And so if you didn't realize, well, what the original intent was behind ISIS, you might be wondering, well, why isn't it working? You know, where did it come up with its router ID? Why isn't it talking to anybody? So we'll get into more about that when we talk about that address. Also, the other difference is, you know, if you capture via a sniffer trace an EIGRP or an OSPF packet, you're probably used to seeing your layer 2 header, your layer 3 header, which is IP, and then your routing header right behind that. Well, this stuff here, ISIS, was not designed around IP. So your sniffer trace might throw you for a loop when you very first see it, because you won't see any layer 2 header, IP header, and then ISIS header, because there is no IP. You'll actually see ISIS right after the data link header. Right after it is where you're going to see it. And that's a little bit of a mind shift there to think about that as well. So just some basic terminology here. Routers are called intermediate systems. So ISIS means one intermediate system communicating with another intermediate system. And hosts, like your laptop, your server, would be called an end system. You know, back when the ISO developed this, they actually developed two protocols. They developed protocols for the host to talk to the router, and that's actually called ESIS. So ES-IS, the ESIS. And that's sort of like in the IP world, that's sort of like, you know, ARP and the Internet Router Discovery Protocol. You know, any kind of protocol you can think of in the IP world where a laptop would discover a router and talk directly to that router. Well, in the old days, ESIS was sort of the equivalent to that. And then ISIS is one router talking to another router. Now, just also a couple of little trivia things. I mean, you would never need to know this on an exam, but I found it kind of interesting, is that the person who actually developed this was Radia Perlman. That might ring a bell, because Radia Perlman also developed a lot of other stuff very famous in the networking world. For example, Spanning Tree, right? Remember Spanning Tree? She developed that as well. I mean, she's developed all kinds of protocols that we now use in the world of routing and switching. She was working at DEC at the time, Digital Equipment Corporation, which I don't believe exists anymore. I think they've been out of business for several years. So she was at DEC at the time she created Spanning Tree. So that's why the original Spanning Tree was DEC's version. Then when they gave it to the IEEE came out with 802.1d, which was not compatible with DEC's version of Spanning Tree. Well, guess what? ISIS originally wasn't called ISIS. The name that she came up with was called DECnet Phase 5 Routing. That's what this was originally called, because it was supposed to operate across DEC systems. So DECnet Phase 5 Routing became ISIS. It was actually renamed ISIS by the ISO. Back in 1988 is when they took what Radia Perlman had created and they renamed it to this. So kind of interesting, because her name is pretty famous in the world of networking. Okay, so if you actually want to dig into the gory guts of this, you can do a Google search on ISO 105.8.9. And now that won't reference IP. When you pull that up, that will all be talking about CLNS, CLNP, and all this other stuff. So that'll be sort of give you the background of why this thing was developed. And if you really want to get the details of how ISIS actually works with IP, then you'll want to go to this RFC right here. RFC 1195 defines how to use ISIS for the routing of TCP IP, which is probably going to be of more interest to you. So like OSPF, ISIS is considered a link state protocol. And so what do we mean by that? Well, you know, what are some of the high-level differences between link state and distance vector protocols? Well, technically speaking, distance vector protocols do not build neighbor relationships. Right? Think about RIP, for example. RIP doesn't discover neighbors. It just blindly sends its stuff out there. Whereas link state protocols do discover neighbors. So in that way, OSPF and ISIS are sort of similar. Another difference, in the world of distance vector routing protocols, if you and I are running distance vector, I'm going to send you some routes. Now, as far as what the actual topology looks like and who the routers are and who they're connected to, the only thing you're going to know is about yourself and me. Because I sent you the routes, I will be the next top neighbor. But behind me, you're going to have no clue as to what the actual topology looks like behind me. You're not going to know who I'm talking to, who they're talking to, who's connected to who. Distance vector doesn't keep track of that information. But link state does. It actually builds a tree and it knows where all the nodes are on the tree and who's connected to who. So in that way, OSPF and ISIS also share some similarities. Now in ISIS, we talk about something called link state PDUs or link state packets. We don't call them link state advertisements. That's an OSPF terminology. And what else? Like OSPF, ISIS utilizes the Dijkstra's shortest path first algorithm. I don't think it does it exactly the same way the OSPF does it, but it does use that algorithm. And like I mentioned, the term integrated ISIS is really what we refer to when we talk about ISIS supporting and routing TCP/IP packets. I'm not going to say integrated ISIS because I'm lazy and it's too long. I'm just going to say ISIS throughout the rest of this presentation. Now, there's a lot of similarities between ISIS and OSPF, so let's go over some of those. And this is why I said in my first presentation that really if you know OSPF, it's going to make understanding this protocol that much easier. Both were designed as interior gateway protocols. Both use the concept of areas. Both of them maintain a link state database, which is derived from the... Actually, the link state database starts out first. That's where you take your LSAs or your LSPs and you put them in there and you sort them. And then from the stuff that's in your database, then the shortest path first runs using the Dijkstra algorithm. It pulls those things out of there. It builds a tree, and it computes the shortest path to any particular prefix. So both OSPF and ISIS sort of do that in the background. Both utilize hello packets to discover neighbors and to maintain existing adjacencies. Both utilize a two-level hierarchy. Now this is going to be a bit different when we talk about ISIS, but the sort of generic idea here is that you've got these areas, whether it's OSPF areas or ISIS areas, and intermediate systems or routers within a particular area, they all know about each other and they all know about the routes in that area. But in order for those systems to know about the routes in a different area, they have to learn about them via something else. Now in OSPF we call that the backbone, and that's a special area called Area 0. ISIS also has a backbone, but it actually does not have an area number. There's no area number associated to it. But you still have this idea of, if you can picture a bunch of circles being areas, and in OSPF, you'd have one long sort of oblong circle in the bottom. That would be Area 0. So all these circles would connect to that, and it would be through Area 0 they'd all be talking to each other. Well, in ISIS, instead of, have your circles, which are your areas, but instead of having another circle down here, which is a different area, instead envision a line. And that line is a continuous line of routers connected to each other that form the backbone. And so all of your areas have to connect to that line of routers, and that backbone allows them to talk to each other and learn about different routes in different areas. And we'll talk a lot more about that as we go along. Some other similarities. So both have the capability of providing address summarization between areas if you wish to do that. Both are classless protocols, so they support prefixes and masks. On broadcast networks, both of them elect sort of what we call a designated router. Now in the terms of ISIS, we call that the designated intermediate system. So we'll talk more about that, but when you see the term or the acronym DIS, that means Designated Information System. Both have the ability to do authentication. Now in this particular series of videos, I'm not going to go into authentication. I don't have anything on that, but it's real easy. If you just do a Google search on Cisco ISIS authentication, you'll find a document. Real simple. It just uses like 3 or 4 different commands. Just as sort of a real high level without going into the configuration, there's basically 3 ways you can do authentication within ISIS, which is kind of neat because OSPF doesn't have this. So with ISIS, you can have authentication just between neighbors. So for example, on an interface, on a link, you could say, well, you two guys, if you're going to talk, you're going to use the password of Cisco. And between these 2 guys, you're going to use the password of INE. So you can do that. OSPF, you can do that too. Then you can take it out a little bit further. You can have something called area authentication. Now this has nothing to do with hellos. Now, as routers are creating their link state packets, they will actually have a field within the link state packet that says, here's my area password. And so now when I receive a link state packet, if the password in there doesn't match mine, I won't accept it. I won't put it into my database. So now everybody in the area has to have the same password. And then to take it out even bigger, you can have domain password where everybody across all the areas and across all the backbone, they all have to share the exact same password. So you can do 1 of those 3, 2 of those 3, or all 3 of those. You know, any permutation of those 3 options are available to you in ISIS. Or you can do none of them. So in all of my examples, I'm not going to be doing authentication. Those are sort of your capabilities there. Now there are quite a few differences between ISIS and OSPF, just some high-level differences here. The administrative distance values are different, right? So you can see here OSPF is actually preferred by Cisco routers. So if you receive an OSPF route and an ISIS route for the exact same prefix, the router will always prefer the OSPF route. Of course, that's configurable. You can change that if you want to. Areas and interfaces. This is probably the biggest difference you got to get your mind around. When you're configuring OSPF, you're probably used to thinking about each link or each interface or each sub-interface being in an area. So that's part of the network command. Or maybe you go to that interface and you say, you are in area 0. This interface is in area 3. So in the terms of OSPF, you could have a router where all of his interfaces are in the same area, right? And we would call that an OSPF internal router. Or you could have a router where it's different, where some interfaces are in area X and some interfaces are in area Y. And if one of those interfaces is in area 0, we call that an area border router. Well, in ISIS, we take the entire chassis, the entire router itself, and all the interfaces on him, and we put it into a single area. So that's a big difference in thinking, that you don't have the idea of areas being tied to links. You have the idea of an entire router being in the middle of a circle, being in the middle of an area. And now where this is really different is, you know, in terms of OSPF, one of the things about OSPF is that 2 routers cannot form an adjacency unless the link they're talking to is in the same area. It doesn't matter if it's area 0 or area 5, the link they're exchanging hellos across has to be in the same area. That is not a requirement of ISIS. 2 routers could have talk to each other on the same link, exchange hellos, and one of them could be in area 5 and the other could be in area 29, and they can form an adjacency. That's perfectly acceptable. And we'll go into more details of that in a little bit. And some of the live audience is saying, as far as authentication is concerned, can we combine them? Certainly, yeah. You could have on your network. You could say, well, I'm going to have a password of Cisco for all my routers in area 20, and I'm going to have a password of INE for the entire domain. So I'm actually going to have 2 different passwords for 2 different levels of authentication. You can certainly do that. Yep. So there are also different rules as far as forming adjacencies. And this is actually kind of nice because in OSPF, a lot of rules for forming an adjacency. And there's a lot of different adjacency types, right? There's two-way, there's the full state, and there's all kinds of states in between. Start, exchange, loading, full. Well, in ISIS, much, much simpler. When we actually get to the section about forming adjacencies, you'll see, wow, that's like totally simple. Actually, it's even easier than EIGRP. So forming adjacencies is, there's almost nothing required, but there's a couple of requirements and we'll talk about those. And also, like I already mentioned, ISIS PDUs, because they were not originally designed to ride inside of or transport IP information, ISIS PDUs are actually directly behind your layer 2 header. So when we start doing some sniffer traces, you'll see you've got your 802.3 header and then ISIS right behind that. That's also a little bit different as well, because in the world of IP, what we're kind of used to is that vast majority of protocols that have something to do with IP, whether it be ARP, EIGRP, RIP, OSPF, whatever, usually at layer 2, they all use Ethernet frame types. In other words, Ethernet version 2, right? Which is your destination MAC, your source MAC, and then your type code. Well, ISIS doesn't use Ethernet version 2. It actually uses, like it says here, IEEE 802.3 frames to carry all of its information. Okay, so in ISIS, routers play different roles. And this is, I can kind of draw an analogy to this with OSPF. You know, in OSPF, you've got internal routers, and all they know about is their own internal area, right? And they don't really have the ability to communicate directly with other areas. They have to learn information about other areas from other kinds of routers, which we call ABRs. Same kind of thing here is true as well, but with ISIS, we've got a lot less combinations. You know, in OSPF, you've got internal routers, you've got backbone routers, and then you've got ASBRs, right? The routers are doing redistribution. Well, in the case of ISIS, instead of having 3 different levels, we've only got 2. Level 1 systems and level 2 systems. And then a system could actually be doing both at the same time, which is called a level 1-2 system. And that's actually the Cisco default when you configure ISIS. And we'll go into the details of this in gory detail in just a minute. So let's look at some next slides here in just a second to go into that. So the backbone, the ISIS backbone, really is dependent on what kind of an ISIS level router you are. Okay, so a router that is going to be either transporting routes from one area to another, well, basically that's a distinguishing characteristic. If a router in ISIS is going to be part of the backbone, it has to be level 2 capable. So that means that router, you've got 2 choices. You can either make that router a level 2 router, or you could just leave him at the default, which is a level 1-2. But it has to be level 2 capable. It has to be doing level 2 ISIS routing in order to be part of the backbone. So let's go into this in more detail. Let's start with level 1 systems. Now you have to manually configure a router to be just a level 1 only system, because it's not that by default. So level 1 systems only keep track of intra-area routing. In order to route data to another level or another area, a level 1 system must send data to a level 2 system. And they will only form adjacencies with another level 1 capable system that is in the same area. So let's go back to the analogy of OSPF. A level 1 system in ISIS would be similar to, in the world of OSPF, a router that has all of its links in one area, and that router realizes that the area he's in is a totally stubby area. So think about that. A totally stubby area OSPF router says, okay, I am not allowed to learn routes from another area. All I'm going to learn about is a default route from the ABR, so that's the only way I know of to get out of my area. And also, let me change that a little bit. I guess a better analogy would be in OSPF, a level 1 router in OSPF would be more like a totally, how do I say this? A totally stubby, not so stubby router. So you know how in OSPF you've got a not so stubby area, an NSSA, and then after that you can say no summary. So you can have an NSSA area, or you can have a totally stubby NSSA area. That's more like what we're talking about here, and here's why the difference is. And let me actually draw this on the whiteboard to clarify this.